Okay, guys, hi. I think I have everything figured out. The only problem I have are these pesky shadows, but we're just going to work with it, okay? So, I promise you a lesson on multiplying and dividing rational expressions, and that's what you're going to get. So, we're going to start off with our lesson on multiplying. So, today we're talking about multiplying rational expressions. Okay? So, we're going to start off with some really simple examples so that you can see that this is really something based on what you already know how to do. So let's take a look at this very basic example. 6 over 7 times 14 over 5. So this problem can be done two ways, but I always say that we want to work smarter, not harder. So you could just multiply straight across the top times top, and bottom times bottom. And that would be totally correct. It would be true. So let's go ahead and do it that way. So I'm getting my calculator, and 6 times 14 is 84, and 7 times 4 is 35. But whenever we do that, we always have to check and see, is there a way I can simplify this term? Well, it turns out there is. It turns out that both the numerator and denominator are divisible by 7. So I could divide by 7 on the top, divide by 7 on the bottom. And when I do 84 divided by 7, I'm going to get 12. And then 35 divided by 7, of course, is 5. And 12 over 5 is the most reduced or simplified version of that answer. However, I want you to take a look at the problem again. And some of you probably already are pulling out your hair saying, no, why did you do it that way? Why didn't you simplify or cancel first? So that's what I meant when I said working smarter, not harder. So we would take this problem, and we can see that 7 and 14 have a factor in common. Now, remember, when we are simplifying, what we're doing here is we are looking for numbers on the top and bottom that I can cancel out. So we're not looking top and top, side to side, we're looking top and bottom. So I see that 7 and 14 have 7 in common as a factor. So 7 goes into itself once, it goes into 14 twice. So now I am left with 6 times 2 over 5, or 12 over 5, which is what we got to start with. So yay. So that means we are doing it correctly. So now let's take a look at a different example that I have for you. So we're going to look at this problem here, and this is 7 over 9 times 3 over 21. And again, I can do some canceling. So I noticed that 7 and 21 have a factor in common, and 3 and 9 have a factor in common. Now, you could also reduce top and bottom, okay? So in other words, I could reduce 3 into 21 7 times and do it that way. So please know that there's more than one approach, and that everyone doesn't automatically see the exact same thing to start with. But I'm going to go ahead and cancel this way. So I'm going to use a color that you can see. So let's say 7 goes into itself once, but it goes into 21 3 times. Because, guys, cross canceling is really dividing by the GCF. And then 3 goes into itself once, and it goes into 9 3 times. So now that leaves me with 1 times 1 up top, which is 1, and 3 times 3, which is 9 on the bottom. 1/9 is the simplest form of this product here, right? Now, if you had canceled 3 into 21, you would have gotten 1 over 7, and then the 7s would have canceled, and you would have ended up with the same answer. All right? So more than one way to do this. I was going to say more than one way to skin a cat, but I realize that's very insensitive. As a former cat owner, I would never do that, okay? So I'm not condoning that. So anyway, let's take a look at our next example. Our next problem is 2x squared over 3 times 9 over 14x. Now notice I have this little comment here. First, what are the excluded values? So we definitely want to make sure that whenever it's required that we look for the excluded values. Now, that question didn't come up in the previous problems because there were no variables. So these were constants. They remain the same. There's no possibility that these denominators were going to change. And so the excluded value question was moot in this case. But here, because I have this variable right here, this x, that means that x can be anything. But because it's in the denominator, we have to remember that dividing by 0 is not defined. And so if you were to do that on a calculator, any number divided by 0, so let's say 8 divided by 0, you get an error message. It says divide by 0. So this calculator specifically tells you, hey, you can't do that, so stop. So anyway, I need to figure out for this problem which value of x will cause my denominator to be 0 or my entire expression to be undefined. So I call the excluded values EVs. So we're going to find our EVs. And so what we do is we look at the denominator. It needs to be in factored form. This is a factored form. We set it equal to 0. And we solve for x, so x equals 0 in this case. So we know at the end when we state our final solution, we need to state our excluded value as well. So moving back over here to this problem, I am checking it out and I see lots of canceling that can take place. So for example, I see that 3 cancels into 9, 3 into itself once, into 9 3 times. I see that 2 and 14 cancel out. So 2 cancels into itself once and into 14 twice, 7 times. And then I notice that I have x squared over x. Now remember, this really means I have x times x on top and an x on the bottom. So one pair of x's cancels out. So I'm just going to cross this x out, and I'm just going to cross that 2 out and put a 1 there for the 1x that I have left. So what I have now is I have an x left on top. I have a 3 left on top. And I have a 7 left on the bottom. So 3x over 7, right? So let's move on to the next problem. Let's go ahead. And x not equal to 0. All right, so our next problem is 15 times 4x plus 5 over 6. Are there any excluded values? Well, in this case, what's the answer? I'll give you a moment. Okay, hopefully you said no, because we don't have any variables in the denominator. Now, you may want to put a 1 under here to help you kind of visualize what's happening. You may also want to put parentheses here, because remember that binomial term represents one single number. And so Now let's take a look at it. Now before you start distributing that 15, we always in these multiplication problems want to check and see, can we do any cross canceling? And the answer is yes, we sure can. I hope you said yes as well. Now 6 and 15 do have something in common. They are both divisible by 3, their greatest common factor. 3 cancels into 6 twice and into 15 5 times. So now let's rewrite this. And some of you may say, okay, well, I don't need to rewrite that. I can go ahead and take the problem from where it is and finish it up here and distribute and all that. And if you're comfortable with doing that, by all means, go ahead and do that. So anyway, I'm distributing that 5, and I get 20x plus 25 over 2. Okay? And then, of course, we have our excluded values. Our excluded values in this case, oh, we didn't have any excluded values. What am I talking about? All right, so let's take a look at another example. This is our final answer here. Now, let's double check though, because sometimes what might happen is that you think you have the GCF and you don't. So you always check. Now I see, 20 and 2, well, they cancel, but 20 and 25 do not. Please, 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 please remember that all of this, 20x plus 25, that's one single number. They go together, okay? They go together. The 20x and the 25 go together. They cannot be split up. Therefore, you cannot cancel that 2 into the 20x, all right? If this 25 had been an even number, then yes, I could divide 2 into all 3 parts of this expression, and that would have been a legal move, but we are done with this problem. Okay, so here's a fun one. I know you can't wait to jump into this one, but first I want to point out something. Don't make this mistake. Again, I cannot reiterate this enough. You cannot cancel things out selectively, all right? So for example, you cannot cancel the x squared with that x squared, all right? You cannot cancel this 3 with the 3 in front of this x, or that 3 right there, all right? Each of these terms, whether they're binomial or trinomial or monomial terms, they represent one single number, okay? However, if we can rewrite these so that we have factors, then we can cancel out factors. So the mistake I want to reiterate is you cannot cancel individual terms of binomials or trinomials, etc. Okay? If they were monomial terms, you could. In other words, like just a single term like that, like an x or a combination of terms that are combined by multiplication, okay? All right. So now we're about to jump into this problem. So again, excluded values are very, very important here. So we need to figure out what they are. And we cannot do that until we go ahead and do our factoring for our denominators. So let's talk about how we're going to do that. So I'm going to start here. So I want to find the numbers that multiply to make 2 and add to make 3. And I can do that in my head. I know that's going to be 1 and 2. And they both need to be positive. Here, all I can pull out is a GCF. So my GCF for this term, it looks like it's going to be x, which leaves me with x plus 3. And then over here, so this is a little bit different because our leading coefficient is not 1. So I'm going to go ahead and work it out over here on the side. So I have 2x squared minus x minus 10. So I'm going to multiply these two together, and I have 2 times negative 10, which is negative 20. So I'm looking for numbers that multiply to make negative 20 and add to make negative 1. And so my choices, oh, you can't see that, I'm so sorry. My choices are going to be 1 and 20, 2 and 10, or 4 and 5. So I can see that's what I'm looking for, the 4 and the 5, because those can subtract to give me a 1. And since the 1 is negative, I need that 5 to be negative. So coming back over here, and I'm going to write that as x plus 4 times x minus 5. So all I've done so far is the work required to see what my excluded values are. So I can take that information from each of these denominators. And so by now we should know that we can just take the opposite. I'm trying to figure out what will make this term equal to 0. A negative 4, a positive 5, a 0, negative 3, negative 1, and negative 2. So my excluded values, I'm going to write them over here. My excluded values, my EVs, are negative 4, positive 5, 0, negative 3, negative 1, and negative 2. It's a lot of excluded values there. So now we have to get back to the problem, and I've got to do some more factoring, guys. So I'm looking at my numerators. And once again, I see that I can factor this top part. I have a GCF of 2x squared. So now, what times 2x squared is 2x squared? 1. And then what am I going to multiply times 2x squared to get 4x cubed? Well, I need a 2, because 2 times 2 makes 4. I've got 2 x's, I need 3, so I need another x. And then moving over here, when I factor this, I need 2 numbers that multiply to make 3 and add to make 4. I can do that in my head. 1 and 3, both positive. Okay, that's a 3. So 1x plus 3x makes 4x. So now let's go down here and kind of regroup all this, right? So I'm going to rewrite it as x plus 1 times x plus 3 over x plus 4 times x minus 5 times 2x squared times 1 plus 2x over x times x plus 3 times x over x plus 1 times x plus 2. All right, hopefully you can see this. You can zoom in and make sure that you always stop and pause things if you get a little stuck, okay? So now let's see, I'm crossing my fingers and hoping I can do some canceling. So I can cancel, let's see, x plus 3 and x plus 3, x plus 1 and x plus 2, an x with an x. And so now let's see what the fallout is. So I have 2x squared left on top times 1 plus 2x over x plus 4 times x minus 5 times x plus 2. So I'm just giving you a minute to kind of take that in. Now, I'm going to pause that.